Hello guys, and welcome to the second part of this isometric game tutorial series that I'm making. We're going to cover a couple of things today, a lot of things actually. The first thing is converting between isometric and Cartesian camera coordinates both ways. We're going to create some view culling, that we only take the tiles from the map that should be visible on the screen. We will zoom the map in and out with the mouse wheel. Two functions for the camera that we can center on a point, like if you want to follow the player around or an enemy or something, or an object that is still, we can center the camera on a point, and we can also center the camera on a tile under the mouse by left clicking. We're going to throw in a character, no animations, just some sprites to rotate a guy walking around on the map. No collision detection in this part. We'll do that later. We will do some scrolling and the map with the mouse. So if the mouse is close to the edge of the map, like the screen, it's gonna scroll in that direction. And we will have two different game modes to switch between: overview mode and object focus mode, which we will cover later on when we get there. Anyway, let's get started. We're gonna start by writing the converting thing here, and I'm gonna show you quickly first. Gonna get a function here, copy a function in from that I've written before, which to speed things up a bit. I can throw this up here like before the int here. Just a function that writes the coordinates for the map to the scroll position and the engine position at the moment. And we're gonna get some can put this actually down here, so when we are scrolling around the map we can see what's going on here, like so. So every time we do something there, we write the chords. Okay. Now there's an old point here we can remove. We don't need. Okay. Build and run. Okay. So when we're moving around here, we can see the different position here, so that's okay. Yeah. All right. So right now we have two different systems. We have two different coordinate systems. That we have the 2D Cartesian and the isometric, and we need to convert between those two. And there's this little floor here that we're gonna change in 2.5. That's gonna be a refactoring thing. That's because if you look here, I'm putting x minus here instead of x plus. So, but for now, for this tutorial, I'm not gonna change that, but I will change it in the refactoring later on. So today we're just gonna write code that's gonna work with whatever we have here at the moment. Okay, so let's get to it. I'm gonna open up our ISO engine here. And we are gonna get some code in here as well. Start. So we're gonna start by converting the Cartesian camera to. We can start by converting the ISO camera to Cartesian here. So we have something in the H file, perhaps. Let's see here, ISO engine.h. Yeah. No, we did not have them here. So it's a memory thing there. Yeah, I used to have them in the H file, so perhaps there should just do some undo here. Yeah, okay, here they are. Yeah. Convert Cartesian like so. Okay. Let's get to it here. The ISO engine T, and like so. And we got the point 2DT. GCMI. We can just copy the floating function in here. Let's get the ISO first. I think we're gonna do it like so. Okay. First of all, we need the point to the point, just 10 point, and we're gonna check if the ISO engine is null, or if the Cartesian cam position is null. If they are, we just return. We'll copy the points, 10point.x, ice engine. Yeah. Scroll Y. So we copy that point, and then we're going to convert that point to as a 2D point to isometric. Because right now we need this is kind of the thing that is the paradox, that we think we're taking an isometric point now to 2D, but we actually have to convert 2D to isometric to skew it around to get the values. So get the point here, 10 point, like so. Then go TMP point dot x equals 10 point dot x divided by 2. Point dot x is larger than 0. So when we are converting the ISO point, we will get the correct y position, but not the correct x position. So as I showed you earlier on, some code will have to change, which will be I will do in refactoring. I can speak today. The refactoring later on. 10 point dot x equals 10 point absolute, because we have to change this to an absolute, and the same thing here, but we have to do it negative. ABS point dot x, as so, and we set the camera position, get the 10 point out. Okay, that should be it. I don't think we have included SDL yet, no, because we didn't need that for the absolution function. Okay. See how many errors we have for that first one. Statement without effect. Yeah, because we have not set an equal sign there. And build. That's okay. Okay. Void convert Cartesian camera. We can copy that as well from the ISO engine here. And put them in the same order that we have them there, so that's better. Copy that in. Okay. So in this function we have to do the opposite as we have in the function up here. So we still need these two lines here, so we can copy them in. So if it's null, we will just exit and say bye bye. I don't want to be in here. And we're gonna copy the point now. TV point equals, we get the Cartesian cam position point, because that's the one we are converting to isometric, and we would divide it up there with 2, so we will multiply by 2 here. 10 point.x multiplied by 2, and we round that out, because the points here are actually in float, so we round them down to I don't think we need that one. You just need to invert the x. We can copy this code here up here exactly as it is actually. Throw it in here. 10 point. And we can, except for one thing, we need to typecast those as well to ints. Okay. And now we convert ISO to 2D and get the point. 10 point like so. And we set the scroll X and scroll Y points there. Okay, I think that should be enough. Build. Yeah, okay, let's try this out. Can go to the isometric tutorial here. And you are writing out our chords, and that's good. So we can take this function here and we can replace this is the extra lines up here. So first we are moving them to the map position. So we can convert. Where did that go? convert. So we will convert to the Cartesian camera position 2. Game.iso engine. And need an ampersand before that. Game.maps 2D scroll position. So like so. We can copy this. Put it down here. Like so. So we're moving those things around now. That's good. Okay. And now we can just remove these lines here. Hopefully, if we have done things right. Okay, build and run. See what happens when we scroll this map around. Yeah, it's working. Up, down, left, right. Oh, you want to see some coordinates perhaps as well. So now you will have them here on the side. So we are moving. See here, everything is moving around here. Close to 0. When we have 0, we can see that these are matching up. This is negative and this is positive, so it's a thing that we change in the refactoring later on. Here we're spreading things out. So it's working. We're converting the 2D coordinates. So let's see if we still have our tile picking working here. Yeah, this one. Get the yellow one, yeah. And this one in the corner there. Next to one. Next to that one, yeah. Tile picking is working. Okay. So I'll be taking a short break and then I will continue with the next part, which is where we have you. There we go. View culling is the next part we're gonna do in this series. So I'll be taking a short break. I've been talking a bit, so I'll be back, and well, you're not gonna notice anything in time because I'll just be going in and out and continue directly from where I am. Okay. Let's see here. Okay, guys, let's continue here. Gonna look at zooming the mouse in and out with the mouse wheel instead of doing view culling. So we take that bit first here. So we add a float zoom level to our structure here. There we go here. Game zoom level equals 1.0. Okay, so let's start by zooming things up here with drawing the mouse first here. Sorry, drawing the isometric map. Sorry about that. And in here we see we have a texture render XY clip. We have to create a new function so that we can draw things scaled up. So the first thing we're gonna do is to fix this. So we're gonna add a function that we're gonna call. We can copy this up here basically, because just one thing is gonna change. XY clip scale here, and in the end we add a float scale like so. And here we're gonna have float width and height, float and def x and def y. Width equals float. We get the texture width here, and +1, and we multiply that with scale. The reason why we are doing this is because later on when we are drawing the map with isometric tiles, there might be some ugly seams that need to be fixed, and just adding this width here a little bit more, it's gonna change that a bit. It's also gonna adjust another place as well. Correct. And move this up here. We call this quad. Diff x equals x multiplied by scale. We go minus x to get the difference in x, and the difference in y is going to be x scale minus y. And we're going to set up the rectangle here. Quad x multiplied by scale minus x. Comma y multiplied by scale minus y. Width and height. So that's our rectangle texture. Oh yeah, and I took the liberty of moving to set up rectangle. So this is moved from the isometric tutorial part here, from the top. Used to be up here before, around here. It's still here, so we can delete that one now. So I've just moved it here into the ISO engine, and I added the here in the H file function call for that. So you know what I've done before, just a little bit in the break here. So we have set up the rectangle, texture, clip rect equals the clip rect, and if the texture clip rect is not equal to null, then we're going to get the quad width equals typecast that to int, the texture clip rect width multiplied by scale, and we're going to do the same thing for the height here, like so. And here is some extra stuff that we're going to fill in. If scale is less than 1.0, or if scale is larger than 1.0, we're going to set the quad dot width height plus equals 1, and the same thing with the quad width. So if I remove this later, it's going to show you what happens when we are zooming in and out. That we get some ugly seams, which we want to eliminate. SDL render copy EX, and it needs to get the render, the texture clip right, the quad, and the texture angle, texture center, and the texture flip type from SDL, like so. And I think that should be it to get everything running. So let's copy this nice function here and put it into the texture here, texture header file, like so. Get back to the tutorial here, and let's see what we got. Back to the draw isometric map, and we go scale, like so. And in here we have to add our scale factors here. Game.zoom level, like so. And like so. I think we should be able to see a scaled up map now. Let's go 1.25 here on the zoom level, like so. Build. Too few arguments. Yeah, because we need to get the gained zoom level here as well. Build and run. Not seeing anything at the moment, so let's see what I'm missing here. Something in the thing here, in the texture. Something that I missed probably. Yeah, of course, this is diff x and not the x and the diff y. So that's why you guys did not see anything earlier on, and you're not going to see anything now either. So I'm just going to have a quick check here what I'm missing. File equal time convert, that should be okay. Get back to the texture quickly and see what's going on here. Get render texture. So I'm gonna have a quick break and see what's wrong here, and I'll be back really shortly here. Okay guys, I'm back. So let's have a look here. Okay, here, scene error here as well. So the problem is here, if we go build and clean, and we go build and rebuild, build and run. That's not what we build, rebuild. Yes. We see that it doesn't know what setup rect does. So we need to include isoengine.h, where we have moved the setup rectangle thing here, build and run. So now we're drawing everything scaled up a bit here, but as you can see now the mouse is now not the right size, so we can change this as well. Back here, so we continue here, we have our draw mouse function here, and the thing is we have to rewrite this code a little bit here so that we can scale things the right way. And what we have to do first is create two things, modulus x. I'm gonna extract this, the last things up here to its own thing here. Tile size multiplied by game.zoom level, and it's gonna be the same for modulus y. So I'm having two two variables here. If you want to change something later, say if you're using a tile size that's not the same size, if y and x are different when you're drawing things. So we got these two, and we're gonna change these lines here. Typecast that to int, and behind here we're gonna put in our modulus x, like so, and we will multiply that with 2. And in here we will put our int, like so, and let's do our, I got a percent there, and modulus y, like so. And then all we have to do now is actually apply clip scale here. And instead of these here, we can go game.zoom level, multiply by game point.x. To scroll, it's not to scroll, but to change these ones up. Zoom level, multiply by that, so we can move this down to get everything on the video, like so. And that should be it for drawing the mouse. Too few arguments, yeah, because we did not pass in the game.zoom level at the end here. Okay, here we go. Yeah. It's nice, it works. See that it's the same size as the tile grid now. It's good. And the third thing to do now is to get mouse tile clicking to work properly here. And we are going to change some code to align for this. First of all, I'm going to create a new function here. I'm going to take this one down here, like so. And we're going to rename this one to get mouse tile position, like pause, like so. And we can copy the code we have up here, the modulus code. These lines, correct accent, yeah. These lines up here, like so. They are basically the same at the moment, x and y, just make sure those are okay. And I'm gonna delete these two lines here, because we're gonna rewrite the code for this. So before, if you look at the code down here, we have set that we can't scroll higher up than 0, so the map will always stay like at the top of the screen. You can't scroll higher than that. So if you do that in the current code, your tile picking is not going to work correctly. So in this tutorial we are fixing that. So if you want to scroll higher up, you will be able to do that. You can just go build. Yeah, it's still around, so I can show you here. If you, here's the map. So if you try to go up, you can go down. And if you go up, you stop right here. So, but if you continue to go up, the tiles will not pick correctly in the current code. So we will fix this. If game.map scroll position .y is lower than 0, because when you're moving up, it becomes positive. When you're moving down, it becomes negative. At least as the system is set up at the moment. Minus equals float ISO engine, scroll Y, minus the tile shift as we had earlier on. We divide this by float of tile size, and then we will divide this by game.zoom level. So what I'm showing you now is how to just zoom in. I'm not zooming out. The math will change when you zoom out less than 1.0. So if you want to do that, you will probably have to go and multiply it by game.zoom level here. So, but I'm not covering that in this series. I'm just zooming things in, at least for the moment here. So, and when we got that fixed, we can go point.y plus equals 1. Else, we're just gonna have this line of code here. Like so. So you can just right here, this is like check for fixing when the Y position is less. Check for fixing tile position when the Y position is larger than 0. The tile, yeah, this is gonna be when the X position is larger than 0. F game.map scroll blue dot X is not equal to 0 but larger than 0. Pointer X minus equals float ISO engine scroll X plus float tile shift X divided by float of the tile size divided by game.zoom level, like so. Then we set point.x plus equals 1. Otherwise, if we're happy scrolling on the other side, point.x minus equals float of the ISO engine, the scroll X plus float of the tile shift dot X divided by float tile size. A lot of typecasts here. Zoom level. And then we will have to set yeah, we're also gonna throw a point out here. So let's do like this. We call this point 2D and we pointer to mouse tile to mouse tile position is good. Should be okay. You can set this to set the X equals int point.x. And we could probably throw in a check here, because it's nice, like if the user has done something stupid. So ISO engine is null, or if mouse tile position equals null. Like so, then we just return. We don't want to cause an error and crash the program because of that. And we're gonna move this code here down here, actually, to this function here, like so. Just gonna make a build, and this won't work if I do that now. We can just type this code quickly here. Point. This is real simple. Point to the T point and get mouse tile position from the function above, and the ISO engine, and we get the point here. I'm gonna save things in the point. There you go. And we make sure the point is within the screen, and then we will set the last time. And we can typecast these ones to int here. That's a good thing too. Like so. How many errors do we have? None. So let's see if this thing works now. Builder 1. we're tile picking the right corner. Yeah, clicking the yellow tile now, and it's changing up here in the corner. It's nice. Yeah, that's good. So we have, there's also one thing left that you can't see on the screen right now because it's not recording the mouse pointer at the moment. Is that we have to correct the mouse pointer as well. And we're gonna do this simply by mouse rect dot x equals game dot mouse rect dot x. There goes my daughter again. And divided by game.zoom level, like so. And this is going to correct for when you're zooming in with the mouse, that if the, say if the mouse position is like here and you're zooming in, then it's going to be the tile, well, the mouse pointer you see on the screen is going to, you have the regular mouse here and the mouse tile will be like down here, so it's going to be a difference like so. And here we go, y divided by zoom level, like that. And here we go. Build, well, still good. So let's write the final thing here. It's gonna be the zoom in and zoom out stuff. And we're gonna call upon the case SDL mouse wheel. Like so. And a break there. So if we have the mouse wheel, we go if game.event.wheel dot y is larger than 1. This is going to be if the user scroll the mouse wheel up, else it's gonna, wow, can't type today. Down, then we will have here else, like so. In here we're just gonna put if game.zoom level is less than 3.0, then we will do the game.zoom level plus equals 0.25. Otherwise we will zoom in a lot. And down here we can just copy that. If this is larger than 1.0, we're gonna go minus, like so. So let's see here if we are zooming in and out now. Building one check here. Okay, pull it down, and with the mouse wheel we can now scroll in and out, and we're still picking tiles correctly. Yeah, that's good. Here's a tile. Can't see it, so I'm gonna click this yellow one here, and it changes properly. Good. So we have now written the zoom stuff as well. So I'm gonna go on here, take a quick break, and be back, and then we're gonna do the view culling. Okay, guys, we should continue here, and this will cover now the view culling. That's what we're gonna do. So I'm gonna head over to Krita and I pre-draw some stuff here. So the way we're gonna do things now is we are gonna use, let's see up here in the corner here, we're gonna go make 2 for loops, and for this is just an example, so we're gonna go just 2 by 2, and we're gonna check here what the tile X position is gonna be. So if we have X here, oh wow, that's a big one. Put it down like 5-6 pixels. That should be better. Okay, so we have X and we have Y here, values, and we'll have tile X here, and tile Y, so, and here we have tile X. So if we go X plus, say if we go like 0, 0, and we have 1, 0, 0, 1, like so, we can make some rows here quickly. And here we have 1, 1, like so. So here's what we're gonna do. Here you have our map, isometric map down here. So we're gonna get the X. This is the same formula as I described in the first tutorial where we this is just a basic isometric formula where you're drawing. Wow, that becomes really ugly. Okay, so we're gonna start by doing this. Tile X, the first one, 0 plus y plus x. So it's if x is 0 and y is 0, we get 0 divided by 2, which is gonna be 0. So tile X is 0, and we know that 0 minus 0 divided by 2 is also 0. And if we go 1, then we go 1 plus 1 divided by 2. No, sorry, 1. So x is 1, y is 0 is going to be 1. 1 divided by 2 is going to be 0.5, which is going to be equals to 0 because it's being typecast to an int. It's always taking everything down. So, and here we go. We know that y is 0. So 0 minus 1 is going to be minus 0. X is going to be... Oh, okay, hey, sorry. Tile y is going to be minus 0.5. And that equals 0 as well. If we do the opposite here, we still get the same result in x. 0.5 is 0. And if we go 1 minus 0 is 1. Then we get 0.5, which is also going to be 0. And if we go the next one in the loop, 1 plus 1 is going to be 2 divided by 2. So it's going to be 1. And tile y is going to be 1 minus 1 is 0. So it's going to be 0. So this is the coordinate 1 but 0. So this is the coordinate we get here from this one. And this all these 3 here, these are 3. All these ones are being placed here, first row here. So this algorithm at the moment is not optimum because we get 3 values, or 3 of these values are actually the same, point to the same tile. So what we can do then is we can eliminate some of these things. I'm gonna show you how we're gonna do that. So if we take the binary system, 1, 2, 3, 4, 5, 6, we got 1, 7 like that. And here, these are all bits, and this one is 1, 2, 4, 8, 16, 32, 64, and this one is 128 over here. 128. Well, you know if you know the binary system. So what we have here is we can set these bits. If all are 0, we get the value of 0. And this can only be, these bits can be 1 or they can be 0. So if I set 3 bits here with 1, they're going to be 4 plus 2 plus 1 is going to be equal to 7. So if I only set these 2 bits, I would have 6. 0 there. So it's going to be the equals of 6. So what we can do now is we can look at this is called the least significant bit, what you have down here. And by looking on this bit, we can know if a value is even or if it is odd. And the way we can check this in C is if we put an if we take the variable, say we take the variable x we have up here, we take the tile x value and we check the tile x value. You can just write down here tile x, and then we can just put an ampersand here on it. But it's better, we're not going to use that in when we're doing the actual algorithm. So we're going to work with the x and y values because these are the ones that we want to filter out, these two. So we can go x, and in C you write an ampersand. Wow, how do you write an ampersand? That was a long time ago. Like so, ampersand 1. And what this does is to test the significant bit, least significant bit. So if the bit is 1, this checks if the bit is 1, and if it is 1, it's an odd number, and if the bit is 0, it's an even number. So when we are drawing, we only have to draw when these two, x and y, are both even numbers, and we skip all the other iterations when we are drawing. So what we can do is just we can go if And then we have our y, ampersand 1, not equals to, or x, ampersand 1, like so. So when we have this, we can just do a continue here. Like so. So this means that if these two are not equal, we're skipping all of these that we have in the middle here that we don't want to draw. So that's basically the quick overview of the algorithm and what we're gonna type and write. So let's get back to the code. I hope that was explanationary enough. A good explanation for you. So it's my second tutorial that I'm ever doing like this for YouTube, so I'm hoping I'm not doing things too bad. Okay, so let's find our draw code. Draw isometric map. So we're basically gonna rewrite this whole thing here. It's gonna look a lot different than it did before. And for this, we're gonna need int x and y, and we can do we have to add two values here. We have to calculate num tiles in width window width divided by tile size, and we divide that by game.zoom level. Then we know the size of tiles that fit on the screen and the width. Num tiles and height, it's going to be the same except for height here. Oh. Like so. But this will be multiplied by 2. And we're gonna get some starting positions as well. And we're also gonna need, we can put them up here. And start X, where we are gonna start drawing. Game.zoom level plus game.map to scroll position.x divided by game.zoom level divided by tile size, and then we're gonna multiply by 2. Start y equals game.zoom level plus ABS. We're gonna have to put an absolute on this one. Game.map to the scroll position.y divided by game.zoom level divided by tile size, and we're also gonna multiply this with 2. And now we get the start position on the map, so we're going to change the drawing loop. We can keep this old one here for now. I start y start y plus num tiles in height, like so. For j equals start x, j up to start x plus num tiles in width, like so. We have the loop set up, and now here comes the part I was just describing for you. J ampersand 1 not equals to I ampersand 1, like so. Then we will continue. Here, skip. Drawing at the We only draw when both x and y is equal. But it's just skip, yeah. So we skip here. Okay, x is gonna be equals to I plus j divided by 2. And y is going to be equals to I minus j divided by 2. Okay, and now we're going to make sure, because sometimes when this algorithm is going through, it might actually trigger, search for negative values. So we can go x is larger than 0, just to make sure that the values are inside of the map. X is less than map width, and that y is less than map height. We don't want to get some phony. We don't want to draw something that doesn't exist. And we can set tile equals world text y x for now. And then we go point.x equals x multiplied by the game.zoom level multiplied by the tile size, same thing we have down there, and plus the ISO engine. Scroll x, like so. We copy that one, we get the point y. Point y. There we go, y, and ISO scroll y. And we convert 2D to ISO, and we get the point in. Then we go to texture. We can just copy that thing down here to save some time from typing. Texture on the clip scale. Here, tile, point x. Yeah, that looks good. So, let's see if this baby is rocking. We missed something. Where did we miss something? Comma before it. Is there something wrong up here? No. Yeah, there we go. They have too many parentheses in the back. So, you can throw this in here anyway. Doesn't matter much. Like so. Build and run. Now, you see if we're drawing the map that we're... Hey, look at that. We're clipping. And right now the tile is the map is very small, so we're gonna change the code down here now as well, so that we can scroll up. We don't care about this restriction anymore. Here we go. Build and run. So now we can scroll up, but look what happens. Wow, it's clipping the top tiles. This is a very simple fix for that, actually. I'm going to show you right now. So that is, if you want to be able to scroll higher up on the map, here's our function. Then all you gotta do is up here on the y, you can say like -10 divided by the game zoom level. And then you have to account for this as well. So here on the height, we have to go +10 as well. See what happens now. Build and run. Here we are. Here's the map. So I'm scrolling up now, and the clipping starts there instead. You see that? So let's see if we can get the y. What do you think? So we try here with like 5 and see what happens. Are we clipping the bottom of the map now as we're scrolling? Not really yet. That's good. So let's fix this as well. Let's see, we gotta make a larger map first. So we're gonna make a generate map function, so we can just, because this is just boring and stuff. So we want to be able to generate the map that it's a lot larger than that. So let's write a quick function here. Here we go. Just call it generate map. X and Y. And we can go like paint tile. So let's just scroll through for Y. 2. 4. Gonna draw a little bit bigger chunks. It's easier for the eye to see where things are when we are gonna do things later on as well. So plus equals 2. Here we are. Go world test. Y. X equals 1. We're gonna copy this down here, and we can go. Just gotta think here. We don't want to paint outside things, so. But we might be able to live with that anyway, because this is gonna be ditched later on, so we might get some memory, write on some memory that doesn't exist, so we can change that. Multiply by 2. Yeah. We might pull it off actually. We're gonna check a lot. Okay, paint tile equals random. This is gonna be removed in the future, so we just go with crashing some memory as well. Right outside things we should not be doing, and I don't recommend you to do this at home. But usually you can do that. If y is less than the map height, -4. So here I'll be taking some precautions at least. X less than map width, -4, like so. You can just copy these things, and we can put in a tile there as well. So in this tutorial we are not covering how to do collision detection and stuff, so we're gonna actually add a second layer for that in the next tutorial, where we will do these things. So I'm not gonna paint tile number 2 is actually a block, and if I paint that, well, you're gonna see what I mean later on when we get there. Paint tile, or leak it to 0, 0. Just equal to 0, 7. That should be enough. You just want to paint it on one value to get some stuff. You can copy this stuff here as well. Generate the quick map, height, width, and we can put tile 3 here. Like so, and that should be good, I think. So instead of having this stuff up here now, you can delete all this stuff here. Map with map value, you can go 64 by 64 instead. And we can just put the generate map function in now in the initialize phase here. And hopefully I will not blow everything up now. Building 1. Yeah, so we have now generated a very large map here. So you see we're clipping in the bottom there. So if I zoom in, it's drawing things correctly. That's nice. So let's find out how large it's going to be in the x-axis as well. We have our draw isometric map. Here on the start x, we can just go, I think it's like -1 divided by. If we go like -2 here or something like that, we can probably see the tile clipping in the end. Hope so. Yeah, here we go. So you see we're clipping tiles now. We're not drawing everything we see. We just pick the stuff we want. So here we have some gray areas here and gray areas there. Good. And the classic example, like as we always want to show sometime, go like so, and height just go like so, and then run to have this nice clipping thing all over the map where we have something. But we're drawing a lot in the Y direction. See here, num tiles in height. Instead, what if we do like that? Build in 1. And then we're just getting half of the screen, so it's doing what it's supposed to do. That we multiply by 2. So if we go -2 here as well and see if we can get some. -5 billion one. Can get some extra stuff. Okay, here we go. So here we are. Now we get this nice gray area around the map to show that we are just drawing the tiles we want to draw from the map. So we're moving down here, scrolling around. So we have now done tile clipping. We're just drawing the things we want to see on the screen. So to wrap this up, we shall not go like -2, and we will go with, and of course you might want to see some stuff up here, so we can go -20 to have a lot a lot of extra tiles in the top. Let me go like +25 or something like that. Or 20. I don't know. Let's try trying to see what happens. Build and run. So this. So we need to add some more tiles there in the bottom, as we can see. Now it's like chopping everything up nice, and they stop drawing. Then when it reaches 0, so we need to add a few tiles there in the bottom. So if we go like 15, we should cover that up very well. But we have to remember we have the zoom levels as well. So when we're zooming in, oh, here we go. This is like, yeah, because we're starting at zoom. Here we are, zoom level. Where are you? Initially here. So we should start with 1.0 so to not confuse ourselves too much with the things we're seeing around the screen here. Draw isometric map. So we probably need to have this like 25. We can try 20 first. Sometimes it's... What? Oh, I got an A in there. Build and run. Yeah, we can rebuild. That's okay. So now, as you can see, we only have this side here left to add some tiles to. One or two rows of tiles extra, and then we are drawing the map as we see it on screen. And we're gonna remove some of the stuff down here. We don't need to write the coordinates out in the window every time we are moving the map around. We could add to the scroll speed here as well as 3, so we can go to like 6. We can start the map at 0. Build and run. So there we go. Now we're drawing. And the final touches on this side here. 20 plus 2 or something like that. You can see we still have a few of those tiles that wants to stick around here. So we'll add +3 here. Build and run. And now, my good friends, we are actually... Oh, okay. We need to add an extra tile here as well. That was interesting. When we were zooming in, it's not getting everything as we wanted it. There you go. Anyway. Is it still having? That's kind of strange. We're getting some annoying clipping here at a few values. So let's add some more here on this side. Like 4. Is that? I hope this will solve the last of the stuff, because it's a tutorial and I don't want to sit here forever. But that seems to fix the problem here. No, some tiles are being calculated wrong down here. That was very interesting. That could be the Y value, by the way. Okay, so I checked the code quickly here, and actually all we had to do was add a 5 here. I modified a little bit to have the whole screen to Now have seamless scrolling all over the part here, so we always see the whole map whenever we are scrolling on the map here, so there's no ugly tile edges here. So that was just a quick jump in here before I'm gonna do the next part. So let's close this one down. And let's start moving on the next part, okay? Which is gonna be centering a camera on a point here. So let's go down somewhere around here, above the draw function perhaps. Doesn't really matter much. So void center map. I'm gonna get the ISO engine in here. And a point to the object point. Point position. So we just copy the point here. And now we will calculate the offset. Middle of the screen. Offset X is going to be window width divided by game.zoom level divided by 2. I want to get the center of the screen. Center is a better word. And of course we will have the window height here. Like so. We should create ourselves a point here as well that we can copy. To copy the object point, a point that we can work on. Can go here for now. Can call this point to the tile position. See where we have our stuff here. Tile position dot x equals object point dot x pointer x, and there we go. Y. Now we will convert the 2D point to isometric here. And we're going to move the X position. We'll floor this one, so when we're zooming things in, we will always snap things to a better position. Point.x. Zoom level divided by 2. And then we will go with offset direct. And we'll multiply this with game.zoom level divided by 2, like so. Yeah. So we will now move the Y position here as well. Again, the map scroll to the position equals floor of the point pause, not was inverting what I typed there before. So dot Y multiply by game dot zoom level, like so, and game dot map scroll to the position dot Y minus, not minus, it's plus equals offset Y multiply by game dot zoom level. And why these are flipped now is because which will be fixed in the refactoring later, it's due to our moving of the camera. Wherein I have stored that code somewhere. Showed that earlier on. We're moving the camera around, that we are looking for the code now, so should be here. Yeah, because we have flipped the X and the Y here, so compared to what we had before. Anyway, let's continue here. Game dot no, convert Cartesian camera to isometric. So we're gonna get, we have all changed the map positions. Now we're just gonna translate this to the isometric camera as well, of where we are scrolling around. Let's see here, ISO engine, and we're using dot map to scroll position, like so. Alright, so we can center a map around a point now whenever we like. But for this to become more interesting, we should actually throw in, we're gonna use this one soon, but we're also gonna we'll make this one as well here, the second part here where we can zoom in on a tile when you click the mouse. So we write that one as well, and then we throw in the character that we can move around the screen. Center map to tile under mouse. Gears of the ISO engine there. Create a 2D point here. Mouse, ISO tile plus. Now we need can copy the offset here, because we're going to use this as well again. And then we have our function here, get mouse tile position. So get the tile under the mouse. We get the position, and then we can copy the position. Yeah, because we throw this out to ISO engine here, and we throw this, we get the point here, mouse tile pause. So what happens here is that we have stored the mouse tile position in the right here. Game dot tile pause dot x equals multiply by the tile size. Copy that, like so, like so. Now we convert the isometric coordinates. Convert 2D to ISO. Convert to, not the. Okay, here we go. Mouse tile position here. Then we move the X position. Game.map scroll.x equals mouse. Whoa, that was not what I wanted to do. Mouse ISO tile pause dot x multiplied by the tile size. Multiply with the game dot zoom level, and finally divide that by 2. And now we will correct our stuff here with the offset. Offset x multiply with the zoom level divided by 2, and then we'll move the Y position of the camera, the 2D. Mouse isotile pulse.y multiplied by the tile size divided. No, not divided, but we're just gonna multiply by game.zoom level here, like so. Game.map scroll to position.y minus plus equals offset y multiplied by game.zoom level. Like so. And then we of course we convert the map to the position to isometric camera. Camera to camera. Convert Cartesian camera to isometric. Iso engine, and we get the point in here, which is going to be game.map to the scroll position. Yeah, that should be it. So what we can do now is that when we left click, mouse button down, instead of getting the mouse tile, we can now go center map to tile on the mouse, and we throw in the game.isometric engine here. So let's see if this is working. Villain 1. Whoa. Yeah. Like so. Villain 1. We are missing some things here. Yeah, we probably don't need that one. That should be good. Well, so we don't know what floor is, so we need to include SDL lib is still there. Okay. Include math page, and we will probably solve that problem. Yeah, build and run. Okay, so let's click here and see what happens. So I'm gonna click this tile here. That means that we will center this tile on the screen now. And that's not happening. So something is a bit off. So as long as I'm clicking on the right side, things are moving as it should. So I need to have a look at this and see what I missed. Go down and see what we got here. Center the map. And we are clicking. Center map to mouse. Tile on the mouse. X equals mouse position here. Dot X. We got offset Y multiplied by the game zoom level here. Y, X, X. It's a bit strange. I have a bit look here and see what's going on. So I think the problem might actually be in here, because right now the point is in. So let's switch this to float. This usually fixes a lot of things sometimes. See what we got here. KXP. Oh, the right chords thing here. So ain't this thing, and also this thing here. And we have to typecast this one as well. Okay, let's see if this rocks now. I hope so. Here we go. Click around. Yeah, cool. So I click this one, it'll be centered there. That's in the center now. Up here. Cool. Nice. We got something working here. Awesome. So this can be used for, say if you have a minimap here up here in the corner or any corner and you just click on it and it will center the map to that tile. That's something we could do later perhaps. Okay. So now we gotta continue to the next part. I'm gonna throw in the moving character here. Let's see here. We are going to create another texture here. Texture T. And what should we call this one? Perhaps, how about we call you... let's call you character. Text. And we need to create some... some character sprites as well. No, character rectangles. Anyway, do I have an image of this one? I might have one around lying here somewhere. I think I have one here. I'm going to show it for you just a second here. Yeah, this little thing is we're going to throw in here. So when we're walking around, we're just going to make have our still shots here each angle, and we're just gonna move that thing around. So this is what you will see, the thing that we are putting in there. And because I prepared some things in advance, I already know the size of these things. Child clip, here we go. X and Y. I need to texture in it on this one. You just copy this one up here. That's nice. And instead of that, we're just gonna go with the character texture here. There you go. No. And 4. Here you go. I have 2, and these are actually 8 sprites that we have to throw in. So we can make it define up here as well. Define num character. Oh, whoa. Sprites 8. Copy that stuff and get down here. Like so. And then we have to set up the rectangles. Characts, the index of that one, X and Y. These are 70 by 102 in size. So that means for every row we will go X 70. We just have one row of sprites here, so we don't have to care anything about it, like switching the Y axis and stuff like that. So let's throw this thing in here, down here with the initializing stuff, like so. And we also have to load the texture here. And I've stored that in my data folder, so it's going to be the same folder. Character text. And it's going to be in data and character.png. PNG. Error, could not load texture, and we already know what that thing is, so something like that. So let's see if we can load that texture up. That I haven't missed something. Yeah, here we go. Num. This was the thing I was supposed to do before, which I forgot to do. Build. Why maybe uninitialized? Well, Y is gonna be always gonna be 0. So let's do this, and then we know that should be okay. Goody good. So build and run, and we're not gonna see the character on screen now, but we're at least the stuff is loading up, and we can see that. So we know that it should have drawn everything up. Not drawn everything up, but loaded the file into memory, because otherwise we would just flown out of the program here. Okay, so now that we have those sprites, we want to draw them out. So you can find draw. You can put it somewhere a little bit further down here. Draw character. Here we go. And we're gonna take the ISO engine. Now there's an in parameter. Point to the T. Point X is gonna be, can do typecaster. And probably game. Share. Yeah, we need to have a character point. We haven't created that yet. We need a point for the character. You can just call it sharp point. Like so. Here we go. SharePoint.x multiplied by game.zoom level. And we don't need all those parentheses. I don't know why I made 2 of them, but plus ISO engine scroll X, like so. Do the same thing with Y here. Translate this to the world coordinates, like so. Convert 2D point to isometric point. Yes, please. Point. And then we have to draw it, and we're gonna draw it with the. This is XY click. We need XY scale thing here. So you can just copy this one for now. And we're gonna draw the character texture. And we're gonna put this on point.x instead of all this stuff here. Point.x. I'm gonna put it on point.y. And we're gonna get the character rect here. Share rects, and we're not gonna draw that one, but we will. For now, we can just put in a 0 to draw the first one, because we have to create when we are walking around some other places. So now we're going to draw the character on that point, and we need to initialize this point, and the in function up here. Game.SharePoint.x equals. We can put it home like 0 and 0. So it's gonna be, whoa, the top of things here. Y. Okay. Build and run. Well, we're gonna draw him as well. That's a good thing. We're gonna draw something. We like to draw everything. Yeah. So we draw the map first, and we're gonna draw this guy in here. Copy that, because that's what we need to have in here. And let's see what happens. Build and run. And lo and behold, there our character is standing. So we got the character in now, and we want to move him around. So let's create a new variable up here in the nice thing here. In game, and not from the game, but character direction. Like so. And this is gonna map to the different tiles we have here. Not the tiles, but the different sprites. Let's get the spritey dude down here, okay? So here we have the different directions. So we have 8 different directions you want to put in. So let's do that. Gonna add some defines now on top here. Define player direction up left. It's the first one. Fine. Player. They're up. Let's do something like that. Not left. Up. Thank you. You can copy at least copy one of them and continue. Okay. 1, 2, 3, 4, 5, 6, 7. So then it's up. It's gonna be up right after this. So we know the images are just rotating around. And then we're gonna have direction right. You see here. Right. And then you have right down and so forth. Right down. Now we down. Down left. And left. Up, left, up, right. Down. It should be down right, I think. It's a better word for that one. Down right. Okay. Something like that. This means we can set the character direction, so one of these in the beginning. Sharp point has been set. Character direction equals player direction down. So let's start having the character looking down at us. And of course game dot character direction. And now what we can do is we can put this guy in here. Where do we have our drawing function here? So we can put in our game character there. Like so. Build and run, which means it's going to be facing down now instead. Like so. And all we have to do now is to add a couple of changes to our nice code here that we have. So it's going to be a couple of long lines because we want to get things in a better way. So for now we can comment these ones out. And you can use them later to move the map around with WASD instead, but we're going to change a few things here. Okay. If the key state is SDL, scan code S. Let's get a copy of that. So for each of these states, we're gonna make sure that we're gonna S, D, A, and W. So let's start with S. When we press the S key, and none of these other keys. Sharp point, we're gonna move the X with equals 5. You can also add a variable if you want for this, but it's a tutorial, so let's keep it like this for the moment. Now we set the character direction to player there down, because S is the down key. Okay, so let's copy this. Whoa, we just got that in somewhere. Nice. Okay. So the next key we will do is W. So let's unlock W over here. That means we're gonna go -5 and -5 on the character point. And we're gonna character direction up. Like so. The next one is gonna be up left, up right. I think will be good. Let's unlock this D key here. Up right. And upright will be just the minus, like so. Can put in some nice else ifs here, so we go through the list. Let's do up left in this one. That will be W and A. That would be X. -5 on that one. So I'm gonna have a quick break here. My daughter woke up in the other room. Be back really shortly here. Okay, I'm back after some checking upon my little daughter there. Okay. I got 3 of them, actually. So, okay. See here. Where were we? Yeah, we just done up left, so we're gonna continue and do the direction right here. Like so. That means we are only gonna press the D key. On top of this, we will move the X with plus equals 5 as well. And soon we're done with all the views here. All the directions here. So that was right, and next direction is going to be the left. And you just flip these two, like so. So left, right, up, left, up, right, up, and down. See what we get from that. Okay. We got a very big movement speed on. Okay, the A key is not responding, so I probably missed something here. Where do we have our left direction here? Yeah, we didn't change these ones here. So we can move into those directions. Up, down. I'm going to add the down left and the down right code as well. Throw them in here. So down left, that's going to be the S key, and it's going to be the A key. They're down left. Like so. What was I changing now? That was not good. Oh, the wrong row. S key and the A key. Next we're gonna go is it Y? It's gonna be Y, I think. Plus equals they're down left. Like so. And then we have down right here. Right and down right is just the S key and the D key. Like so. And then we go X plus equals 5. I think that should be okay. Yeah, we are moving around the screen here in all the directions. So, but now we can't scroll the map, so let's add some scrolling to the map here. So what we'll do is we'll go to the main function here and we set gonna think a bit if there's a special place for this. I gotta remember, because there's a way to lock the mouse to the window. Just gonna think for a few seconds here to get that thing in my mind here. That should be like this. SDL, show cursor. You haven't ever seen the cursor anyway because I'm not recording it, but let's do like that. And once we've done that, we can set SDL, set window, grab, and we go get window, like so, and we can get SDL true here, like so. That means we focus on the window, and then we go SDL warp mouse inside the window, get window, and then we're gonna go window width divided by 2, window width, window height divided by 2. So we initialize the mouse in the center of the of our of our screen there. So that's the first thing, and then we are going to write a little function here. We could just do like this. What? Scroll map with mouse. So first you're going to calculate where the edges are. So we window with multiplied by the game dot zoom level to count for that. And then we're just gonna see window width. What's left once we have zoomed. Zoom edge Y is going to be the same there. Zoom with window height, multiply by game zoom level, and window height here, like so. And we can go again the mouse rect. Dot X is less than 2, so or if the game mouse rect dot X is larger than window width minus the zoom edge X divided by the game dot zoom level, and go minus 2 because we have 2 pixels on that side as well. And copy these things here. Throw them down, and we go Y instead. Y and window height minus zoom edge Y divided by zoom level minus 2. I'm completely looking at the wrong line here. Sorry about that, guys. Stop doing that to me. Okay, zoom edge, zoom level minus 2. Okay. So if we're there, we're just gonna go map screw position, and we can go map scroll speed. And of course, we're gonna move on the x-axis here. And what we do then is we convert Cartesian camera to the isometric here. Iso engine. So we are following along like so. Let's throw these things in here and change them accordingly. And then we go plus equals. Plus equals, and we'll adjust for that. And if it's the y, we'll just go y. Plus equals, and the y minus equals. See if that is gonna work now. And of course we have to add this thing up here. If we're gonna test it up, we need to put it somewhere in like in the update function here. Like so. Build and run. Gotta pull this down for you, and it's locked inside now. So we can scroll the map with the mouse now. Like so. And we are near the edges. Cool. So what we can do now is we can try the center point function here as well. I'll look a bit at my notes here. So every time we are moving around, this will actually nullify the other thing, but let's see here. So every time we update, we can throw this in here. Center the map on the game.sharePoint instead. Like so. And go build and run. So I gotta pull this down here. So now we are focusing upon the character here. Like so. See, we have some glitches when we are zooming in and out here. But what we can do is, to fix this, every time we zoom, where are we? Here we go. Every time we're doing this, we can center the map on the game, on the character position here. Like so. And go build and run again. Get this thing down here. So if we zoom in, that glitch is gone. As you can see now, the character is more and more is not really centered because we have not taken in the account of the character width and height and divided by 2 to really center that thing on the screen. So we can hard code that in now just for the tutorial purpose to show you what you need to do to get it centered. Just gonna find my draw character function around here somewhere. Here we go. And now we're gonna add the stuff we need to do. Actually, not here. We're gonna do it on the center map function instead. So let's see here. Gotta find where it's supposed to be here. It's in the center map, yeah. Okay, sorry about the delay here. I'm thinking a bit, and should be around here. The map scroll to the position. So if we all right now we're doing this on the thing, so we can account the x value first here. I can just go game.map. Scroll to the position dot x plus equals 45. Why 45? Well, because our sprite was, as we can see up here, it was 70, and 70 divided by 2 is 45. And multiply that with the game.zoom level. and we divide that by 2. So now we have accounted that for that thing. So right now we're taking in the point. Later on we should take in a whole object, and then we can in the object we will have the width and the height, and we can account for these things right in here. So we know that it will automatically be adjusted to the right center position no matter what the object is. We're going to do this for the y as well, the y value here. Game.map scroll to the position dot y minus equals 102 divided by 2, and it should be 51, so we can type 51 instead, and we can go multiply by game.zoom level like so. So we can remove the parentheses. Let's run that again. Build and run. Let's see what happens here. Okay, here we are, and now the character is okay. I think I missed something here. Somewhere around the edges I missed something. Somewhere. Yeah, gotta think a bit about this and see what the problem might be. And it shouldn't be that hard. Yeah, this was a problem here. We had plus and then we go minus here. But then 1. See here what happens? Like so. Now we're assuming things in and we're centered on the character. And now if we're clicking, you see everything is jumping because we said that we should be going to a particular tile when we were left clicking. So let's just create 2 game modes. This is the final part of the series here. Toggle between game modes. So we will add 2 game modes today. Define game mode overview 0. Define game mode object focus like so. Find num game modes. We have 2 game modes. And of course we will have a little thing here and game mode, and we should initialize this in the init function down here somewhere. So which one should we go with? We could go with the overview first. Game dot game mode equals game mode overview like so. So we can go to our update function here, and if we are game.game mode is equal to game mode object focus, then we want to do we want to center around our nice little thing here. Else if the game.game mode equals game mode overview, we will do scrolling the map with the mouse. And if we go to our center map, wherever that is, here we go. Alright, not on the tile but our other function, here we go. And if we are scrolling, if the game.game mode is equals to game mode object focus, then we will do this for the character only. Right now this is hard-coded and ugly, but who cares? It's a tutorial. Game mode equals game mode object focus. Then we will do this, otherwise we don't. Like so. And then we will add a thing down here. Key up, we'll add case SDL K space. We are pressing the space bar. I don't want those. Just want to wipe my brake. There we go. Okay, and then we set game mode, game mode plus plus. And if the game mode is larger or equal to num game modes, then we'll do this. Game mode equals game mode overview. So we go back to the first defined view that we have up here. That's a 0. So if we add more game modes, we can just press the space bar and toggle between those. Okay, I think is that everything? No, we're gonna change. Let's find. Should be down in the mouse wheel thing here. Yeah, we need to fix things here also. If the game mode equals to game object focus. No, game mode overview. We can center the map around the game dot tile game dot isometric engine first, and then we can get the game dot tile position. So when we are in overview, we will focus around those things, and game mode equals game mode object focus. Then we will do this like so. Now we have to do the same for this one down here. So we can copy this code here, and we can throw that in here like so. Build and run. See if we can get this down for you. Okay, here we are. Now I press the space bar. You can see we are walking very fast in the left and right direction. So you can adjust that as well. But for now, I press the space bar. We are scrolling with the mouse on the edges. If I press the space bar, we are following the character around. Press the space bar and he can run away somewhere else. We can look upon other things. We can focus on them by pressing space bar again. So we have two simple game modes here. And right now, if I left click, oh yeah, we gotta change that. We have yet not fixed the left. Here we go. If the game mode equals game mode overview, then we will get the tile clicks. Get the tile out of the way. If the game mode equals game mode, not overview, object focus, we will do this and center the map around that. Under the mouse. Get mouse tile click in the overview. See if this was correct or if I'm mistaken here. So you get this thing down here. Well, it's okay. We're getting the tiles now in overview. If I press spacebar, we should not be doing that. This one should be flipped. Like so. I think here, we center, we click. Yeah. Like so. Go build and run here. See what we get. Spacebar is clicked. Now we're tile picking. That's what I wanted. Here we go. So basically this is the end of the tutorial here. Now we can move left click. We are moving around the map. Centering the mouse points. And if you press spacebar we can do tile clicking. Okay. That's the end of tutorial part 2. The next part, it's actually gonna be part 2.5 and part 3. In part 2.5, I'm gonna refactor the code because right now this is just a one big mess with everything basically in one single file with all the things here. So we're gonna change things a bit, and the refactoring will be covering also creating a dynamic map. We're gonna use malloc to allocate the map. And we're gonna put everything in one pointer instead of dividing those things, so we will have a contiguous memory and stuff like that. But that's in part 2. But for now, I hope you enjoyed this part. I'm not the best coder in the world, but I enjoy making video games and I enjoy coding. So I hope some of you guys enjoy this and get some use of it. You find some usage of it. As usual, I can't speak in the end of the video or something like that. Anyway, take care guys, and bye bye.